Hello everyone, welcome back to the channel. I am Nikhil Kumar. In our last video, we have explored pods, the smallest unit in Kubernetes, and learned how to create them with and without YAML. We saw that while kubectl run is quick, but YAML manifest file gives us better control and reusability. But pods are not self-healing. If a pod crashes, Kubernetes won't automatically bring it back. That's why we need replication controllers, ReplicaSet and deployments. Today we will break down these concepts and do a hands-on demo to see them in the action. Why do we need replication? Imagine running a single Nginx pod and it suddenly crashes. Then our application will not be accessible anymore. Kubernetes won't restart the pod automatically. And there will be no scalability, so you can't handle more traffic. And there will be no hireability as well. So there will be a downtime for your application. But Kubernetes has a solution for this, that is replication controllers, ReplicaSet and the deployments. Let's see them in the action one by one. Let's start with the replication controller. That is one of the earliest ways Kubernetes lets us manage multiple copies or replicas of a pod. For example, if you need 3 Nginx pod, it ensures that exactly 3 replicas of same pod are always running. And if the pod dies, it recreates it automatically. Let's try to create a replication controller using the YAML file. So this is our Kubernetes cluster. So let's try to create our manifest file, that is rc.yml. First we need to specify the API version, that is v1, that is similar to the pod manifest file as well. Then we need to specify the kind. Here we need to provide the replication controller, and then we need to specify the name under the metadata. So here I am giving a name, that is my Nginx RC, and here we need to specify the spec of the replication controller. First of all, we need to specify the replicas, like how many replicas we need. So here I am giving 3. Then we need to specify the selector. So basically the selector app web is looking for a pod with this particular label. Then we need to specify the template. Inside the template we define the pod using the Nginx image. So let's give a metadata here. Metadata, and here I'm giving a name to this particular pod, that is my Nginx. Then specify the labels. So I'm giving a same label which I gave into the selector, that is app web. Then we need to specify the spec that is used for the pods. So here I'm going to create one container, so containers, and the name is Nginx and the image is Nginx. And here I'm also specifying the container ports, so specifying the ports, that is container port 80. So our manifest file is ready. If you notice, I specified the same label which I specified in the selector section. Basically this particular selector will always look for the pod which is having the same label, and it will try to maintain the same replicas if the pod got deleted with the same label. Let's try to create a replication controller. So kubectl create -if and the rc.yml. Replication controller got created. Let's see the pods, and we can see the 3 pods are running. Now let's try to delete one of the pod. If we delete this, it will recreate the another one to maintain a 3 replicas of the pod. This is why the replication controller is super powerful. It always look for that particular label which we specified in the selector section, and if any of the pod got deleted with the same label, it will try to maintain the same state or desired state of the replicas. If we see the kubectl get rc, we can see my Nginx rc is having a 3 desired, 3 current and 3 ready. So it will always try to maintain the 3 desired, and whatever we specified in our desired state, that is 3 as of now, so it will try to maintain the same. But replication controller is now outdated. It only supports exact match selector, making it less flexible. That's why Kubernetes introduced ReplicaSet. ReplicaSet is an improved version of replication controller that supports more flexible selectors. Let's try to create a ReplicaSet now. Let me delete this. kubectl delete -f and rc.yml. Now replication controller got deleted and we see pod also got deleted. Let's create another file called rs.yml. So here also we need to specify the API version, but this time we need to specify the different API version, that is apps/v1, and kind is replica set, and metadata that is same, and here I am giving a name that is my Nginx replica set, and spec section. Here also we need to specify the replicas first, that is 3. Now we need to specify the selector to look for the selected labels, but this time under the match labels, that is match labels to match the pod. So here I am specifying the same label, app and web. Then we need to specify the template. The pod template is pretty much the same. It runs an Nginx container on port 80. So let me update it very quickly. Labels, app, web, and spec, that is containers. Nginx and image and the ports, and specifying the container port. The complete manifest file is same as replication controller manifest file. The major difference is the API version, the kind, and the match label is being added here. Let's try to create a replica set using this manifest file. So kubectl create -f rs.yml. Replica set got created. Let's see the replica set. We can see the same structure which we saw in the replication controller. Let's see the pod. So pods also got created. Let's try to delete one of the pod. Pod got deleted. Let's see the same thing again. It also did the same thing which replication controller did, but ReplicaSet supports more expressive selector and is what backs deployment under the hood. Let's try to scale the ReplicaSet using the kubectl scale rs my Nginx rs with the 5 replicas. And let's see the pods again. We can see the 5 pod is running right now. Basically, ReplicaSet can automatically adopt and manage existing pod that match its label selector, something replication controller can't do effectively. But here's the thing, we still don't have rolling updates or rollback capabilities. That's where deployments come in. Let's talk about deployments, which are the recommended way to manage application in the Kubernetes. Just like before, we define the number of replicas and the pod template in the deployments as well. It also allows us to easily perform rolling updates, rollbacks, and pausing or resuming the deployments. And we can scale the pod easily using the deployments also. Let's try to create a deployment using the manifest file. So let me delete this. Oops, I'll delete. And if we see, all the pod got deleted. It will be exactly like ReplicaSet. So let me copy the rs.yml to deploy.yml. and made the necessary changes in this. So API version will remain same because deployment will be using ReplicaSet internally to create or maintain the replicas of the pod. So let me update the kind now. So kind will be deployment and the name is deployment, and rest of the thing will remain same. So let's create a deployment kubectl create -f and deploy.yml. We can see deployment got created. The deployment got created and we can see 3 out of 3 pods are running and it's up to date as well. Let's see the pods. We can see the 3 pods are running and we can see it is being created by the deployment because our deployment name is coming with it. And let's see one more thing, that is ReplicaSet, because deployment is using the ReplicaSet internally to maintain or create a pod. So as we can see, it is being created by the deployment. Let's try to do some rolling update with this particular deployment. So kubectl set image deploy and the deployment name, that is my nginx deployment, and nginx equal to nginx 1.21. We can see the image got updated. So let's see this. Kubectl get pod. So 21 seconds ago the pod got recreated, and let's try to describe the pod. And we can see the image got updated to 1.21, which we specified just now using the set image command. And let's see the status of rollout. Kubectl rollout status and the deployment name kubectl get deploy and the name is my nginx deployment. So we can see it rolled out successfully. Now if we want to undo something, if something went wrong, so we have a command for the same. For that we can use kubectl rollout undo and the deployment name, that is my nginx deployment. It rolled back to the previous version, and if we see kubectl get pod, the pod is getting recreated again with the older version of the image. Let's check the pod again. Kubectl get pod. We can see the pod got created, and let's try to describe this. Kubectl describe pod, and we can see the pod got updated to the latest version. Deployment is very useful. It automatically manages ReplicaSet, it supports rolling updates and rollbacks, and it scales easily with the kubectl scale command as well, just like we did in the ReplicaSet. Now you know the difference between ReplicationController, ReplicaSets and the deployment. In our next video, we will cover Kubernetes services including cluster IP, node port and the load balancer. So stay tuned. Don't forget to like, share and subscribe for more content like this.